Good morning to everyone. Today I am going to present a seminar on number system. So before talking about number system, we'll talk about a small topic which is called conversion of binary code to gray code. Binary code and gray code are two codes which look alike. Binary is a number system which is used in computer languages. It only consists of two numbers 1 comma 0, and to convert this into a gray code, uh, we need we need to know about the truth table of XOR gate. The XOR gate is a gate which consists of two inputs and a single output. So the XOR gate provides output 1 or true when both the inputs are different, and when both the inputs are same, the output will be 0. So we'll observe the truth table first. So so as we observe the truth table of XOR gate, we we will observe that when the inputs are same, the output will be 0, and when the inputs vary, the output will be 1. Using this XOR gate truth table, we'll convert binary code into gray code. So here I am considering a binary code, for example, 110101. So to convert this into a gray code, we have to observe two elements, which is a starting element in the binary code and ending element in the binary code. So these both are called most significant bit and least significant bit. The starting number of the binary code is called as most significant bit, and the last digit of the binary is called as least significant bit. So to convert this binary code into a gray code, we have to note the most significant bit as it is in the first place. So I am noting down 1 in the gray code, and next we have to do the XOR gate to the preceding two terms of the binary code. So and after doing the XOR gate to the preceding two terms, we have to note down the resulting value after the most significant bit or the first value in the gray code. Like when we do the XOR to the first two digits, which is 1 comma 1, the output will be 0. So I am noting down the output 0 after the most significant bit 1 in the gray code. Next I have to do the XOR gate to 1 comma 0, which are the preceding two terms. Next preceding two terms. As the inputs vary, the output will be 1 in XOR gate. So I am noting down the value as 1. And next we will do the XOR gate to the next preceding two terms, which are 0 comma 1. As they both vary, the output will be 1. So I am noting down the 1 after that, and the next terms are 1 comma 0, and when we do the XOR gate to 1 and 0, as the inputs vary, the output will be 1. The next terms are 0 comma 1, which will be resulting as the value 1. So this is our gray code after converting into gray code. So uh, this is how you convert a binary code into a gray code, and we can also convert the gray code into binary too. So to do this conversion, let's take the example of this converted gray code, and we'll convert it into binary, and let's see the value. So I'm recording that 101111 as it is a gray code which is converted previously. So now to convert this gray code into a binary code, uh, we have to write the most significant bit uh, in the initial position. So I'm noting down one as the initial number of binary code. So this is great binary code. So we have to do the XOR gate to the resulting binary value and the next term of gray code. So we have to do the XOR gate to the converted binary value and the next term of gray code. So when we do the XOR gate to 1 comma 0, uh, we'll be having the result as 1, because when the outputs vary, the sorry, when the inputs vary, the output resulting value in XOR gate will be 1. The process will be repeated for every term and the converted binary value. Next we'll do the binary conversion, and we'll do the XOR gate resulting to 1 comma 1. So as the both the inputs are similar, the output will be 0 in the binary code. Now we'll do the XOR gate to the 0 and 1. As the inputs vary, the output will be 1. So this is how you convert a given gray code into a binary code. So the next topic that we are going to talk about is called as number system. Number system is a way to represent numbers using symbols or digits. Each number system is categorized with its base or radix, which tells us the how many digits it uses. We have different number systems which are stated as 4 types. The first one is binary. The second one is decimal. The third one is octal. The fourth one is hexadecimal. So in binary, we have the base or radix as b or 2, because it consists of only two numbers. The base 2 represents that number of how many digits uh, the respective number system consists of. As the binary system consists of only two digits which are 0 comma 1, the base and the radix will be represented with the number 2 or the letter b. The decimal system consists of 10 digits which are initially started from 0 to 9. So the decimal values, so the decimal one will be represented as with the base or radix as a 10 or d, as it consists of 10 digits. The base is represented as a 10. uh, so the digits are starting from 0 to 9. Its base or radix is 10 or d. So a decimal number is represented with the base 10 or d, and the binary is represented with the base 2 or b. The next number system we are talking about is octal number system, which consists of obviously 8 digits, which are 0 to 7. It is represented with the digit 8 or O. And the next one is the most important one. I mean, it's important because it is a little bit confusing, uh, because it also it solely does not consist of only numbers. It also consists of um, alphabets. uh, so it consists of 16 values. From 0 to 9, it consists of numbers, and the capital A, which is stated as 10, and capital B as 11, capital C as 12, and capital D as 13, and capital E as 14, capital F as 15. So totally it consists of 16 values. So this is represented with the base or radical as radix, or uh, as a 16 or h. So these are the number systems which we just discussed about. So we'll talk about another topic too, which is converting a. So now we'll convert decimal number into a binary number. So for example, we'll take a number noted as 122 122. So as it is a decimal, I am representing it is its base or radix with a 10 or d. So I'm taking 10 as the radix or base. So I'm taking 122. So to convert this into a binary number, we have to divide it by 2 and note the reminders in each step. So the first one, when we divide it with 2 in the first step, we'll get a quotient of 61 and a remainder as 0. So I'm noting down the remainder sideways. Second time will be 30 and 1, and the third time will be 15 will be the quotient, and 0 will be the remainder. 7 will be the quotient and 1 will be the remainder. 3 will be the quotient and 1 will be the remainder. 1 will be the quotient and 1 will be the remainder. So this is how you convert, by dividing the decimal number into with 2. So as I noted the reminders, start from the lower one, which is a quotient 2. Will write the binary will be 1 1 1 1 0 1 0. So this will be the binary of the decimal number 122. So I am representing it with the base or radix 2. When we have a decimal number with a fraction value like 122.45, we will first note down the reminders of the uh, 122, which is a non-fraction value. So as we already noted down the binary of non-fraction value 122, uh, I will just show you the how to convert the fraction value into a binary one. So to convert a fraction value into binary one, take the fraction value and we'll multiply it by 2. As we are having the fraction value in 122.45, we are having the fraction value as 0.45. So I have to multiply it with the digit 2, I will be noted the answer as 0.9. So I am taking the number 122.45, the 122.45. As I already noted down the binary for 122, I am doing the fractional part. I am converting the fractional part into a binary one as a next step. As I multiplied 0.45 into with 2 and got the answer as 0.9, I will take the value as 0. Its binary first digit of the binary will be 0 after the fraction value, and again 0.9 will be multiplied with 2 and we will have the answer 1.8. I will note down the binary value as 1. As the fraction value consists of only two digits, 4 comma 5, so I am noting down only two binaries after the fraction, after the point. uh, I got the values as 0 comma 1, so the binary will be uh, double one double one zero one zero double one double one zero one zero point zero zero one will be the binary for 122.45. So this is how you convert uh, decimal value into a binary one. I have shown you two ways to convert a normal decimal value into a binary one and fractional part by decimal value into a binary one. So thank you one and all.